Hey everybody, we're going to do a quick little video about tangent and then reciprocal graphs all together. These tangent notes are on the graphing trig functions notes from last week. I'm just adding some tangent sections in here. So if we go back to that first page of the notes, we made a table about sine and cosine and tangent as we were going around the unit circle. Again, just a refresher, remember cosine is the x term and sine is the y term. So then we talked about then tangent was y over x. So what we're doing is we're going to take sine over cosine, or y over x, the points around the circle at those degree angles or radian angles. And so if I take 0 divided by 1, I get 0. 1 divided by 0 is undefined. So those are the values that we had kind of come up with for tangent. Well, that doesn't seem super helpful to just have 0 undefined, 0 undefined, 0 undefined. So we threw in a couple other values. So I picked what I called the kind of the in-betweener points here on tangent. So halfway between 0 and pi over 2 is pi over 4. Okay, and so this is a little bit different as far as the scale goes. There's some more information in here. And I didn't go from 0 to 2 pi. I actually went from 0 to pi, and I went backwards to negative pi, because once you start seeing this graph for tangent, you're going to kind of notice it's a little bit different. So if I start at 0, my first point is 0, 0, and then at pi over 4, I go up to 1, and then at pi over 2, it's undefined, so I have an asymptote, okay? And then at 3 pi over 4, which is halfway between pi over 2 and pi, we're at negative 1, and then we're back to 0. So technically that is a full cycle right there, but it looks a little funky. So if we fill in the rest of it and kind of go backwards, I have this negative 1 point and then undefined and then 1, 0 again. And so we can kind of start to see that right here, if I go from negative pi to, over 2 to pi over 2, that's my full cycle. Okay, I like going from the asymptote to the asymptote. So when I find this period is actually pi, right? I've got negative pi over 2 to the left and positive pi over 2 to the right. Add those together, that full distance is pi. So that's one thing that's a little bit different about tangent. Obviously, another thing is that it's got some asymptotes. So most of the graphs we're working with today, I think actually all of them do have asymptotes, because there's places where we divide by 0 and that is undefined. So the 5 key points of tangent would be, I would start with the asymptote, then the min, then the 0, then what I'm calling the max, and then the asymptote. Now I realize that these are not actually the min and the max, I'm just calling those them, so then they're similar to what we were working with on sine and cosine last week. So if we fill in some of these key features, my amplitude is going to be what we're calling the max and min. I guess we should put quotes around them because they're not actually the max and min, but these two values are going to be for the y value, whatever the amplitude is. So here the amplitude is just 1. Period is going to be pi over b this time, because the original period of just the tangent function is pi, and then c and d are our normal phase and vertical shifts. So we already went through some of those notes last week. If we look more specifically at tangent graphs, the period is, that should be pi over b. I need to change that. I don't know what happened there. This should be pi over b, not pi over a. Sorry about that. We'll just get rid of that little tail. Fix it up. There we go. Okay, so the period is pi over b. The asymptotes are going to be pi over 2 and then times n. We'll call that pi over 2 times n. That just means times multiples of that period. So I can repeat in both directions. Again, periodic functions repeat. Okay, so then I don't know why some of these didn't show up, but if I look at 2 tangent of theta, my amplitude is 2, and then my period should just be pi. So when I set this up, I like to take that period length and I divide it in half, and then I go either direction to make those asymptotes. That's what I like to do. And then I like to find the middle of that, and that's my 0, and then what I call the quarter point. So halfway between here is going to be my min, which is going to go down to negative 2 because my amplitude is 2, and then halfway between the 0 and the asymptote here should be my other quarter point, which is my max, which is going to go up to a +2. And then I can just repeat that curve as I go. So another pi direction this way, asymptote halfway in between is my 0, halfway between here again is my min, halfway between here is my max. Okay, for this next one, this time the amplitude is 1, and then the period should end up being pi over, let's see, pi over 1/3. So if I take pi over 1/3, right, that's going to turn into pi times the reciprocal. So that actually equals 3/1 times pi, so 3 pi. And so I'm going to actually erase this one and just start from scratch because there's not much there, and I actually don't like what's going on here because I think that was incorrect. Sorry about that. But we are going to take a look at 3 pi. So half of 3 pi is 3 pi over 2. So each of those are going to be my asymptotes. I think I forgot to divide on this one, or maybe I was taking 2 pi divided by 3. Sometimes I do that, and you got to be careful too when you're finding the period length, because it is this time pi over whatever it is. So I think that might have been my error. So this should be 3 pi for the period. Okay, so I take that number, I divide it in half. Those are my asymptotes. Halfway between is my 0. And then halfway between these are going to be my max and min. So my halfway point here should be down to -1. My halfway point here should be up to +1. And then I'm going to try my best to make it sort of a curve. These end up kind of looking like cubic functions in a way, but we're going to kind of make a curve. That one wasn't too bad. Okay, and then I could repeat that if I go on. I don't know if I have that much room. I could put my min there, I suppose, and my max here, but it's just going to be a little curve this direction, a little curve this direction. Yeah, so that's what we've got going on with tangent. I'm going to leave this next page blank. If you want to try to practice it, I can put those complete notes on there. I want to just pause for a minute and go to the calculator. So last week I was talking about mode. Right now you can see my mode is in degree. So I'm going to arrow down to radian, and I'm going to hit enter. Okay, now that I'm in radian form, if I go to y equals and clear these babies out, I can type in here my tangent function. So I can say tangent of 1 divided by 3 times x. And it's fine if I use x, even though it says theta on the paper. Okay, and then for my window, I'm just going to go from negative to pi. Where is my pi? Over here. And then to +2 pi. And it really doesn't matter. You can adjust it to however you want. And then I'm just going to go for my interval by pi over 4. Okay, and then I'm just going to go from -5 to +5 and kind of bring in that window a little bit. It's not a big deal. It doesn't have to always be this. You can kind of adjust it. But see, this is pretty similar to what we just saw, right? So if I'm tracing, I have 0, 0. If I type in, let's see, we were at -3 pi over 2. If I type that in, it should be undefined. That's where my asymptote occurs. Okay, and then if I type in, what was my, let's see, my asymptotes were at 3 pi over 2 and -3 pi over 2. If I go to, let's just do 3 pi over 4. Okay, so that is my max, and then we've got the min. Okay, so quick scenario about how to graph tangent and then how to use your calculator. You can also go to Desmos. Okay, so I will post these completed notes on Classroom. Now we're going to jump to graphing reciprocal functions. So on these, what I tried to do is graph the original function. So sine, its inverse is cosecant. So the way I thought of these is just the inverse 1 over 0 would be undefined. So everywhere there's a 0 for sine, that's where my asymptotes are, okay? Everywhere there's a 1, 1 over 1 is still 1, so those points are there. And then everywhere there's a negative 1, same sort of thing. And then just from experience, I know that the point should go the opposite direction. I hope that kind of makes sense if you think about 1 over 1/2 becomes 2, right? So just some values like that if you try to plug them in. But so this kind of looks like parabolas in a way, right? And so one whole period goes from 0 to 2 pi. So I should have one little loop-de-loop this way and one this way. So it's kind of, oops, completely, I don't know what just happened. I wasn't even pushing my mouse. It's kind of completely the opposite, right? It's like you take this and you flip it this way, and you take this and you flip it this way. Same thing then with secant. I graphed my cosine function. Everywhere there's a 0, that's where the asymptotes are. Where there's a max, then we have a parabola that opens up. Where there's a min, we have a parabola that opens down. Same thing from 0 to, computer was checking for updates. So I hope that kind of makes sense. 0 to 2 pi is my period again. The amplitude is still that distance from 0 to the, or from the x-axis to those kind of parabola-looking values. Cotangent, again, looks really funky because tangent looks funky. So everywhere tangent is normally a 0, right, at 0, and then the next interval, that's where we have an asymptote. Okay, everywhere there is an asymptote in the original tangent function, that's where our 0 occurs on cotangent, because you're taking 0 over 1 is now 1 over 0, and 1 over 0 then becomes 0 over 1. So that's where the asymptotes and the zeros come from. Okay, so this is just kind of a brief overview because this is optional. I'll post some other videos from Khan Academy probably as well. I didn't do these outright, but I just wanted you to practice. So cosecant and secant still have that same period of 2 pi, and then cotangent is just like tangent where it has that period of pi. Okay, so you can go through and practice some of these if you'd like. There's an assignment about it that you can do for extra credit this week. It's not required. I would probably look at the tangent stuff just to kind of make sure you understand it, because the 3 main trig graphs that you need to know are sine, cosine, and tangent for next year. It's nice to know about reciprocals, but you definitely will dive into that more next year if you take college algebra and trig, or if you take pre-calc. So yep, here's your video. I'll post some notes here shortly too with the complete.